Hey folks, welcome. In this section of the course, we're going to talk about application deployments with CloudFormation. So using CloudFormation to create infrastructure, known as infrastructure as code, is a common technique that a DevOps professional will need to master. The code is a CloudFormation template which describes the infrastructure that will be deployed. This results in a CloudFormation stack created from the template. So, throughout this section of the course, we're going to work with CloudFormation templates, and in particular, we'll create a stack containing an auto-scaling group of EC2 instances backed by an Amazon RDS database. So, this section will cover several ways to work with the stack using creation policies, helper scripts, stack policies, wait conditions, and update policies. In addition to that, we'll talk about deployment strategies. When you get to the AWS DevOps Pro certification, it's very important to understand how different services can interact with each other. And specifically, in this case, CloudFormation can interact with OpsWorks, Elastic Beanstalk, and even a non-AWS tool such as Puppet. So in deployment strategies, we will talk about these interactions. So some of the key concepts of CloudFormation, as mentioned, CloudFormation gives us infrastructure as code. The code comes in the form of CloudFormation templates. The templates define a set of resources, and upon implementation, these resources are a stack. Now, being that CloudFormation is infrastructure as code, keyword being code, we can version control our infrastructure, and this is hugely valuable. This encourages automation, and we can automate our infrastructure. Automation gives us a repeatable, reliable, and consistent environment. So, let's go into CloudFormation and take a quick look. Now, if we have any existing stacks, this page will show those stacks. But we don't, so we can go ahead and create a stack. So let's click Create New Stack. All right, now I'm going to click Design Template. We could actually paste in a template in either JSON or YAML format. I'm not going to do that for now, so I'll back up. So I'm going to select a sample template, and there's many selections, but I'm going to keep it simple. Come to a page of CloudFormation templates, and I'm going to select S3, Amazon S3 bucket with a deletion policy. And note, I can launch right from here, but it's going to take me back to this page. Your options are to upload a template to Amazon S3 or provide a URL to an S3 location, and the selection of the S3 sample provides us with this URL. So let's click Next. Have to provide a name. The name is provided within the template. So let's click Next. And options, we can just click Next through the options, and we can go ahead and create. Going to refresh, and we'll see the progress of our template. And this is really key. We can monitor the creation progress of our template. Now, if there is any problem at all, we will see a rollback. And this status is going to provide us with information. And if we get a rollback, we will get information on the error that was encountered. And it's a great troubleshooting help. So while that's building, go over to the diagram. And again, the starting point for this is a CloudFormation template. And we place our template into an S3 bucket. And as we just saw, we go into CloudFormation and we create the stack. The template contains all of the resources that we want to build. And the stack, I always like to make the comparison with object-oriented development. In object-oriented development, you have a class, and you have an object. The object is the instantiation of that class. Likewise, you have a template and you attempt to build the stack, and the stack is the end result. So this stack could be anything, but I'm using the example of multiple instances in 2 availability zones. Each have a RDS database fronted by an elastic load balancer. This can all be built with one template, but the advantage of using CloudFormation, we could do this with multiple templates. Let's say we had a database group. So we could have a database stack. We could have an EC2 stack. We could have a front-end stack with elastic load balancer, with internet gateways. So we could have multiple groups, database group, an application group, a networking group, all working using their own templates to create our infrastructure. Another thing we can do, and we'll see it in the next lesson, is we could have CloudFormation create our stack containing our instances, but then we could have another tool such as Puppet provisioning those instances. So there's a lot of flexibility, and you're not locked into one way of working with CloudFormation. Just jumping back over to the management console, we see that our stack completed successfully. There's no rollback, therefore no errors. And let's just expand. This was a very simple template, but they can become much more complex. And the key point to note is that if any part fails, the whole stack will be rolled back, unless you take means to pause or stop a rollback, which we will talk about later. We have a running stack. Now, what if we wanted to make changes to that stack? Well, we can update a stack. I'm going to click on the key points. I have a little bit more information in here. And again, just to review, CloudFormation is infrastructure at code, which can be version controlled, encourages collaboration, and can be automated. You can use a single template to create an environment or use multiple templates, and we can interact with other tools such as Puppet. And we can update stacks. So examples would be changing the AMI of our instances, updating a CloudWatch alarm, updating auto-scaling groups. And there are multiple ways to update a stack, but primary way would be to update the template and then update the stack with this new template. Now, it's important to understand that only the resources within the template that have changed will be updated. So when we update a stack, this status is going to change to update in progress. Now, again, we could have errors with an update, in which case there will be a rollback, but assuming the update completes successfully, the status will change to update complete. Now, it's important to realize that there certainly can be issues with updates. Updating resources can cause downtime. IDs might change. Public IP addresses might change. Or an instance might need to be stopped. And let's think about AMIs. AMIs are an immutable property of the resource. So we can't simply stop and start the instance to change its AMI. We have to completely replace the instance. So I'm going to go over to updating a stack, update stack. And again, first of all, we would provide a template. I'm not going to go through with the update. Just wanted to point out that when you're performing an update, there are opportunities to review your update before actually going through with the update. Now, in the real world, some of your stacks are going to be production stacks. And you don't want just anybody being able to update or delete your stack. And that's where stack policies come into play. So stack policies can be used to prevent resource updates. They are JSON documents similar to IAM and bucket policies. So a stack policy applies to all users who have access to the stack. And again, similar to IAM and bucket policies, they allow or deny actions on resources within the stack. So, the important considerations for updating a stack. How will the update affect the resource? Will it cause downtime? And if so, is there an alternative approach to avoid this downtime? Is the change mutable or immutable? And again, the example, if you have to change the AMI of your EC2 instances in an auto-scaling group, you can't just change the existing instances. You have to replace those instances with new instances made from the new AMI. And how will these changes affect the rest of the environment? So those are the things that need to be considered. So what about rollbacks and deletions of stacks? Now, rollbacks happen automatically, but it's not always the case that you would want an immediate rollback. The thing about rollbacks can provide protection because once you begin creating a stack, you are charged for those resources. So a rollback eliminates those resources. If you have an incomplete rollback, you can have resources that you are being charged for even though you don't have a functioning stack. But you can change the default behavior to not roll back. This will allow you to investigate the resource that caused any issues. You can check logs, figure out the problem, and then manually delete your stack. And again, any rollback information can be found in the events of your stack. And it's extremely helpful in troubleshooting. And the very key point about rollbacks, if anything fails during stack creation, the whole stack will be rolled back. Now, some common reasons for a stack deletion to fail. S3 buckets, for example. S3 buckets need to be empty before they can be deleted by CloudFormation. So that's kind of protecting you in a sense. CloudFormation just isn't going to zap your S3 bucket if there are contents within the bucket. Resources may have dependencies that need to be deleted first. Good example of this is nested stacks. So there are dependencies between those stacks, and those dependencies could prohibit you from deleting a stack. And finally, for CloudFormation, you need to have permissions to create, update, or delete all of the resources within your stack. You need to have appropriate permissions. So your deletion could fail if you do not have those appropriate permissions. Now, rollback failure reasons, again, nested stacks could be an issue, dependencies between those resources. And here's a big one. When you update stacks, it's best practice to update through a template, through CloudFormation. Now, if you go in and update a resource within the stack outside of CloudFormation, which you can do, your stack is not going to be in sync with your template. And that can cause some problems with rollbacks. So we've covered a lot of concepts in this lesson, but throughout the rest of the section, we'll go into much greater detail. So go ahead and mark this lesson complete, and let's move on to the next.